So we are continuing with our overview of various effects and surfaces type in Cine 4D. So let me just select this light and I will filter it out here from the filter menu. It's kind of in the way. Much better now. Let's create a new material and apply it to this test plane we have. We'll open it. I'll disable this specular once again. Here under effects, the first guy we will talk about is ambient occlusion, which is really special and can be used in many ways, but mostly is used as a self-shadowing feature, as some alternative to global illumination, and as a dirt shader. So let me do a preview render of it. And actually, to see the effect of ambient occlusion, you have to have some sort of irregularities in surface. So let's do just that. I will temporarily clear this. I'll simply select this loop, this outer loop. So we have to check this boundary loop option and extrude it downwards. And maybe I could select few of these faces in some random manner, something like this, and extrude them downwards so we have some sort of irregularity here. Let's open our material window. You see, I always open this extra material window. I find this little window in Attributes Manager a little bit too small. So I really like to have a floating window. That's my workflow preference. Of course, you can do anything you like. So now if I do a test render here in our viewport, oops, I just accidentally deselected. And if I do a test render here, you will see that you can actually see that there are some indentations and irregularities and extrusions in that surface, but that looks really undefined and it's really hard to see what's going on here. So to get this surface to show a little bit more definition and depth, you can enable a shadow. So let's do an area shadow. I will just set this accuracy under shadow tab to 10% so we have a really faster render. It will be a little bit grainy, but that should not bother us. You can actually see now that this surface looks much more better and clear and defined. You can actually see where those indentations are. It's not flat. So shadows can help a lot. But in the real world, I will disable this to none. In the real world, there is a sort of self-shadowing feature, and that is exactly what we will use ambient occlusion here for. So let me load that shader in, ambient occlusion, and you will immediately see the effect. So where two surfaces like here meet, just like in the real world, it will be darkened. So it simulates the light behavior between surfaces. And if you go inside that shader, you can find many settings. You can actually use this shader as a lighting feature. If you put it in a luminance channel and put it on a sky object, you will be able to light the scene. Some of these settings are, let's say, somewhat technical. I really want to show you just this accuracy feature. Keep it around 50%. And rather than increasing accuracy, increase this minimum and maximum samples. As I will explain this minimum and maximum samples settings, it's found commonly in Cine 4D. So when I explain it on one place, it's 100% applicable to any other feature. The main reason why I'm telling you to keep this at 50% is that this ambient occlusion is really computationally intensive if you use higher accuracy values. And according to that, if you're using higher values here in minimum and maximum samples, the render time will increase also. So one major advantage of ambient occlusion is that you actually change these colors and you can use any gradient that pops to mind. So let's, for example, load this maybe color we haven't used yet, something like greenish. And you will immediately see the effect in the viewport. And the reason why you want to change this color is actually when you have scenes that are dark, or really just to put a really strong color in to see exactly where your ambient occlusion starts and ends, and how dispersed is it, and so on and so forth. I showed you the usage of ambient occlusion in color channel. The most used channel for ambient occlusion is this diffusion channel. And let me show you something. If I simply copy this to a diffusion channel, simply clear this under color and enable diffusion, you will see something happening. And here we have a problem. No matter what color you set here, it will convert it to grayscale values, so values of black, white, or anything in between. To resolve that, you can use this ambient occlusion in another channel, or if you go here under render settings, here under effects, you can apply ambient occlusion for the whole scene. So if you want to have self-shadowing, then you can completely get rid of this material and have ambient occlusion on the scene as whole. And you will be able to change colors for that ambient occlusion. Let me just demonstrate this. The reason why you can use ambient occlusion as a shader is to isolate it on a single object or a few single objects. So once you have a really complicated scene, ambient occlusion can really slow things down. Okay, let's go to our next guy. I'll disable this. And you can delete this test plane. So let me create another shader so we can experiment with another effect. And the next guy here is called Backlight. So let's create another plane, scale it a bit, rotate it a bit in the scene, something like this, pull it up a bit, and convert it to a polygon object. So Backlight shader is really conceived as an option for you to mimic when something is lit, when you can actually see the light coming through the object. So for example, imagine those materials on the bed lamps or something like that. So I will enable this light again in the viewport so I can actually see it. And I can use, without manually positioning this, I can actually go here under transfer and transfer this plane to this light, and I'll just uncheck this enable rotation so it will not rotate as the light is rotated. So let me pull this a bit, something like this, and I can apply this backlight shader to it. And if I render it now, this is what you get. So let's open up the shader and see exactly what is going on there. And the best place to use backlight shader is this, or any shader that involves something illuminating or something that has, let's say, some scattering inside the object, is best to be loaded in this luminance channel. So now we have a completely brightly lit object by this luminance, and we can't see absolutely nothing behind it. So let's load here this guy, this backlight guy, and see what happens. And now we have something happening here. If I pull this a bit outwards, so this light is not so intensive, let's see what we get. Actually, this effect is really subtle now, but let me just select a color for my light. For example, a yellow one, something like this, and see what happens. So now it's a matter of experimenting. So you can actually pull it closer and see when you will get a nice effect. So here we go. Now we can actually see that there is light penetrating from the inside of this shader. So You can increase the illumination. So let's say, for example, 200 and see what we'll get. And the overall effect will be so bright you won't see that gradient from the light that is behind. So let's try 100. That's too much. Let's try even lower value, something like 20. That's too low, maybe 50. With shaders, it's all just a matter of experimenting. Now, when you have some, let's say, properly backlit object, you can play with other channels, for example, with transparency to get the desired look. I think that pretty much covers it for the backlit shader. I really don't use it much, but I had to show you that function. So let me delete this plane. I will put my light back to completely white. And I can delete this shader and we can go to our next guy. And our next guy is, let's see, is Chanlum. I believe that is pronounced like that. And this guy is really interesting. It's quite difficult to explain this shader, but I will give my best. Firstly, we will create an object sphere. We're gonna scale it a bit, pull it upwards a bit, and convert it to a polygon object. I can also put it under hypernurbs so we can get those nice smoothing. These illuminating effects that have luminance, lum, or scattering in the name are best used in luminance channels. So let me load this Chanlum here and do a preview render and see what we get. For this shader to work, you have to have the light source, not the default auto light, it won't work with it. You have to have actual light source and you have to have shadows enabled. So let's do that, and we have somewhat different result. So rather than explaining you, I will show you with some colors what this shader can actually do. Firstly, this shader won't work with colors unless this mix mode is set to multiply. So let's do that. Let's try with some color here. For example, let's try some orangey color, and we will apply that material to our sphere. See what happens. And here we have something really interesting. This shader is really designed to mimic the scattering, but only on the surface. For example, you can create velvets, rubbers, or you can even create fruits, and you can create sponges or stuff like that. So if you, for example, put another color here in the color value, so let's do something crazy. Let's put, for example, a red color. You will actually see that red color comes here first. So let me play a bit with colors. We could set a red color here, very strong red, and let's say some sort of a violet blue color here, and let's see the results. And you can actually see we have some sort of velvety, carpety look. You can do pretty lot with this shader, but you will have to experiment with it. And currently this is a bit grainy because my area lights shadows, I can close this, are around 10%. I can take this to 50% and see if I get something different. You can already see much more definition in the surface and in the shadow itself. It still is not nowhere near close enough, but it's a start. And also you have in the shader itself, you have a samples value. So if you can enter something really high here, for example like 50, you will get completely different results. The surface will be much less grainy, it will be much more smooth and exact. See, it already bogged down my computer, along with this recording it really is slowing me down. Here we go. This shader will pretty much work on, let's say, human skin, maybe even cloth objects. It has so many uses that it's really hard to take something out and say this is the shader exactly for that. Unfortunately, this is a multi-purpose shader. Okay, so let's go with our next guy. Simply close this, delete that material, and create a new one. And the next guy we have to deal with is the Distroter. And this one is really interesting. Let me show you what I mean. I'll just zoom out a bit, something like this. And if you enter the Distroter shader, you will see quite a few options, but don't be scared by that. This shader takes the texture or any other shader and distorts it with any other shader or texture. Let me demonstrate that. It can sound a little bit complicated, but it's really not so. Let's, for example, load a noise shader here. Say maybe this one. I will apply it to the sphere and looks decent enough. Here I can distort that very same noise. So for example, if I want these straight lines to be a little wobbly, I can use another noise to do just that. So for example, something like this. And you could now possibly, let's say, color this first noise that is distorted with this other texture. I know this all is a little bit too technical and boring, but trust me, you have to have a reasonable basic understanding of those shaders, and later everything will come and sit as it should. So let's say you want to color this actual noise. For example, you would do that with colorizer. So I actually have one little idea. For example, what if I shade these black areas with a different color? Just invert the value. If I right click here and select invert nodes, that is exactly what I will get. Let me control drag this one to create a small thingy here. And what I'm actually trying to do here is to show you how to build some sort of a lava rock shader. So now we have a white part. We will need maybe a orangey part, something like this, and maybe red part, something like along these lines. Let me render it. Okay, something along these lines. Maybe this noise is even too big, so I will increase the scale to, let's say, 200. Let's see what do we get. Okay, something along these lines. And since I absolutely adore this displacement, I will load this into displacements channel also. I will copy it, enable displacement, and simply paste. You see I have some crazy results. So let's invert the height to -5 so the shader works the opposite way. Something like this. That's a bit too much. Maybe -2 will be just enough. And I will enable this sub-polygon displacements and see what do we have here. And now it's really good at subdividing those pieces, and we have some sort of a lava styled basalt rock shader. It's just a quickie. You have to understand, to create a really good procedural shaders, you have to invest some time. So let's recapitalize on that. We have a simple distorter shader with our actual texture that is colorized with a colorizer, and the noise that actually distorts this shader. So we can tune down maybe this a bit, and we will get a different result. And we'll see that things look a bit off because we have to use the same value here in the displacements channel, or it won't match. Let me see now, and you can actually see that now those things do fit perfectly. And what if you enable glow? something like this. So just a quickie, and we have some sort of lava burning. Ooh, it's hot material here. So it's just basic. You can build magically good procedural shaders with Cinema 4D. I will show you that. So let's proceed to our next lesson.